Now that we have an idea of the likely charges an element will form, we can use that to figure out what ionic bonds will be created to form a different chemical. So in forming ionic compounds, which are compounds made from ionic bonds, the ions will come together in a way that balances out their charge. So when sodium and chlorine ions form ionic bonds, it typically comes in a large compound like this. And so we have a chemical formula that's going to express the ratio of sodium to chlorine atoms in the crystal of sodium chloride. Since sodium is a +1 cation and chlorine is a -1 cation, if I bring these together in a 1-to-1 ratio, then for every positive charge that I have, I'll have a negative charge to balance it out. So it'll have an overall charge of 0. If I look at something like calcium and fluorine forming a bond, my calcium has a +2 charge, and my fluorine has a -1 charge. So if I brought these together in a 1-to-1 ratio, I would have an overall positive charge associated with the compound. And that isn't something that happens. We always have a neutral compound that doesn't have a charge. We always need something to counter a positive or negative charge, rather than have a lot of just one build up. So if these combine in a 1-to-2 ratio instead, we would have the +2 from our calcium, and we would have 2 -1 charges from our fluorine. This would balance out to an overall charge of 0. And that's why calcium fluoride forms a compound that has 2 fluorine atoms for every calcium atom. So we have a different ratio. So let's look at how to write a formula for an ionic compound if you're just starting with the elements. So let's take the example of, how about aluminum and chlorine. So for aluminum and chlorine, we need to first identify which one is the cation and which one is the anion. So the cation is typically the metal. If you don't follow those guidelines, it's going to be the one with the lower ionization energy. So the one that's easiest to form a positive charge. In this case, it'll be aluminum, our metal, and our anion will be our nonmetal chlorine. Now I'll figure out the charges on these next, so I can determine how many of each ion type I need to get an overall charge of 0. So my aluminum will form a +3 because it's in the group 3 of my periodic table, and it has 3 valence electrons, so it'll lose all 3. Chlorine is group 7, so 8 minus 7 will equal 1. So my chlorine will have a -1 charge when it's an ion. So I'll be bringing together an aluminum +3 and a chlorine -1. I need to figure out how many I need of each to be able to balance out to an overall 0 charge. If I had just aluminum and chlorine, then I would have a +3 and a -1 coming together. This would have an overall +2 charge still associated with it. So I can't bring these together in a 1-to-1 ratio. To get that negative or that 0 charge, I need 3 of these -1 charges from chlorine to balance out the +3 of my aluminum. So I would write this as aluminum chlorine with 3 chlorines. And I would use a subscript to say that I would have 3 chlorines in this compound. And this will have an overall charge of 0. It'll be +3 plus 3 times -1 will equal 0. That's my double check. So when we write our formula, we make sure that we always place our cation first. So the aluminum is written first, followed by the anion, which is the chlorine. And I put my 3 subscript to show the number of chlorines. And it's important that when I'm writing out my chemical formula, I omit the charges unless there's an overall charge associated with the compound. And in this case, there's not, because we've balanced that away. Sometimes when you look at the charges of your two ions, it's not really clear right away exactly what ratio you need to combine them in to make sure that you have an overall zero charge. And that's when we can use what we call the Criss-Cross Rule. It's where we take the magnitude of the charge, and magnitude of charge is just saying the size of it. So oxygen has a magnitude of charge that is -2, and aluminum has a +3. We take that charge and make it the subscript on the other atom, or the ratio of the atoms that we need to balance out our charge. So this 2 will become the subscript 2 on aluminum, and the 3 charge of aluminum will become the subscript 3 after oxygen. These aren't charges, these are ratios, so we don't use plus and minus. So my aluminum will combine with oxygen in a ratio of 2 to 3. And let's multiply this out. So if I have 2 aluminums, each with a +3 charge, and I add to that 3 oxygen atoms, each with a -2 charge, this is going to equal +6 plus -6, or 0. So I've brought these together to get a overall 0 charge. And this is essentially a kind of different presentation of finding the lowest common denominator between two things. So aluminum 2O3 would be our chemical formula. Here